Hi, I'm Patrick Reagan. Welcome to the Advanced Networking Concepts, Part 8, Streaming Media and CDNs. During this video, we will cover two technologies that you encounter as a network administrator, including Streaming Media and Content Delivery Networks, or CDNs. While these topics are not part of the Network Plus exam, they are very common in today's network. As always, stick around for the practice questions at the end, test your knowledge, and help you prepare for the Network Plus exam. If you find this video helpful, don't forget to click the like button. And if you have not already, subscribe to the Pat Has Your Back channel for more tech training content and technical know-how. Let's start with streaming media. Streaming media refers to audio or video content delivered continuously over the internet and played in real time on a user's device without requiring the user to download the entire file first. This technology has become the dominant method for consuming digital media worldwide, enabling on-demand access to a vast library of content. When a user requests content, such as a movie on Netflix or a song on Spotify, the media file, which is stored on remote servers, is broken down into small data packets and transmitted to the device. The streaming process involves several steps. Capture. Audio and video is captured using devices like cameras and microphones. Encoding. The raw data is compressed and converted into streamable digital format using encoder software or hardware so that it is efficiently transferred over the internet. Distribution. The encoded content is sent to an online video platform and distributed to viewers via CDN using specific protocols. Buffering and playback. The end user's device temporarily stores or buffers a few seconds of the stream to account for network fluctuations, then decodes and plays the content using a media player. The preloading helps ensure smooth, uninterruptible playback even if the internet connection speed fluctuates. As the content plays, new data packets replace the old ones, and once a segment is consumed, it's typically deleted from the device's temporary cache, which saves significant storage space compared to traditional downloading. Streaming and video technology typically using UDP protocols because of the low overhead associated with UDP, including not waiting for acknowledgments that reduces latency. Also, keep in mind that if you're watching streaming media, it is often not a big deal if you miss a frame or two, which you will not even notice. A codec, short for compressor decompressor or coder decoder, is a software algorithm or hardware device used to drastically reduce the size of digital audio and video files for efficient storage and transmission over the internet. The primary purpose of a codec in streaming is to enable high-quality media delivery without overwhelming network bandwidth. Without codecs, the raw data for video would be enormous. A 90-minute ultra-high-definition UHD video would be several terabytes in size, making streaming impossible for most users. The codec process involves two main stages. Encoding compression. On a streaming platform server-side, the raw media is compressed into smaller, more manageable digital format. The codec uses complex algorithms to identify and remove redundant or less perceptually important data, a process called lousy compression, which significantly shrinking the file size. Decoding or decompression is when a user streams the content. Their device's media player uses the same codec to decompress the data in real time, reconstructing the audio and video signals for seamless playback. Popular codecs for streaming video include H.264/AVC, which is the most widely compatible standard, H.265 or HEVC, which is sufficient for 4K content, VP9, which is used extensively by YouTube, and the newer royalty-free AV1. Streaming protocols are standardized rules that dictate how data packets are transmitted from a server to a client device. HTTP live streaming, or HLS, is widely used for its compatibility across most devices and web browsers that support HTML5 video players. Dynamic adaptive streaming over HTTP, or MPEG-DASH, is an international open source standard similar to HLS used by major platforms like YouTube and Netflix. Web Real-Time Communications, or WebRTC, is an open source protocol for ultra-low latency, primarily used for real-time communication applications like video conferencing and live gaming. Real-time messaging protocol, or RTMP, a legacy protocol still commonly used for ingest or transmitting the stream from the broadcaster's encoder to the streaming platform server due to its low latency for that part of the process. And adaptive bitrate, or ABR streaming, which this technology detects a user's current internet speed and device capabilities, dynamically adjusting the quality of the stream to prevent buffering and ensure smooth, uninterruptible playback. Streaming is used for a variety of content types. On-demand streaming, which allows users to access pre-recorded content such as movie, TV shows, and podcasts anytime they want. Examples include Netflix, Hulu, and Spotify. Live streaming, the broadcast of an event over the internet as it happens in real time. This is common for live sports, news broadcasts, concerts, and video game commentary on platforms like Twitch and YouTube Live. Game streaming and cloud gaming. This offloads the processing demands of video games to a powerful remote server, which streams the results back to the user's device, removing the need for a high-end local computer or console. Key benefits of streaming include instant access, where playback begins almost immediately without waiting for a full download. Flexibility and mobility, where content can be accessed on a wide range of internet-connected devices, including smartphones, smart TVs, game consoles, and computers from almost anywhere with an internet connection. And cost effectiveness, where subscription models often provide access to vast libraries of content at a lower cost than purchasing physical media or extensive cable packages. When using streaming media, the main networking concerns involve bandwidth, stability, network congestion, and latency, all of which can directly impact the quality and reliability of your viewing experience. Streaming high-quality content, especially 4K Ultra HD, is data-intensive. User Data Protocol, or UDP, is often used for streaming media because it prioritizes speed and low latency over perfect data reliability, which is acceptable for real-time applications like live video and audio, and it has a tolerance for packet loss. UDP operates on a best effort delivery model, essentially sending the data and moving on without waiting for confirmation of receipts, which allows the stream to continue flowing continuously even under challenging network conditions. UDP supports multicasting, which allows a single stream of data to be efficiently sent to multiple recipients simultaneously, which is valuable for live broadcasts to large audiences, optimizing network traffic. Streaming media can be affected by the following. Minimum requirements. Most streaming services recommend a minimum download speed of about 25 megabits per second for a single 4K stream. For HD, 1080p, around 5 megabits per second is a typical minimum. Multiple devices. These requirements are per stream. Multiple devices in your household are streaming gaming or downloading large files simultaneously. You need significantly more total bandwidth. For example, 50 to 100 megabits or higher is often recommended for multi-user homes. And data caps. 4K streaming can consume a large amount of data, up to 7 to 14 gigabytes per hour, which can quickly exhaust data caps if your internet service provider or ISP imposes them. An unstable connection causes buffering, lagging, and drops in quality, even if your maximum speed is high. Wired versus Wi-Fi. Ethernet connection is highly recommended for stable, high-quality streaming, especially for live events and 4K content, because it provides a direct, dedicated connection, less prone to interference than Wi-Fi. Wi-Fi signal strength. If using Wi-Fi, distance from the router, physical obstructions such as walls or metal objects, and signal interference can weaken the signal. Using a modern router such as Wi-Fi 6 or a mesh network system can help. Streaming can be affected by network congestion. Peak usage times. Network speeds often slow down during peak usage times, such as evenings, due to many users on ISPs shared local networks simultaneously. Background activity. Background applications and processes on your device, such as system updates, cloud syncing, and other browsers tabs can consume available bandwidth. Latency is the delay between when content is sent and when it is received and displayed. Live stream and impact. For on-demand content, latency primarily causes buffering while the video preloads. For live streaming, such as sports and gaming, high latency is a significant concern as it causes noticeable delays between the live event and your screen, hindering real-time interaction like live chats. Streaming media can have security concerns, unauthorized access, or piracy. While streaming on legitimate platforms is generally safe, using illegal streaming sites can expose your device to malware or phishing attempts. Secure connection. When accessing sensitive information, using HTTPS adds a layer of encryption to protect your data from man-in-the-middle attacks, especially on public Wi-Fi networks. Let's shift gears to discuss Content Delivery Network, which is used by streaming media as well as other services. A Content Delivery Network, or CDN, is a geographically distributed network of servers that works to accelerate the delivery of web content, including HTML pages, images, and streaming media, to users by bringing the content closer to them. CDNs are widely used for much more than streaming media. They form the backbone of the internet, accelerating web performance, enhancing security, and delivering static and dynamic content like images, website code, software downloads, gaming data, and e-commerce transactions to users globally. This includes the following: website performance optimization, accelerating page loads by caching static assets such as images, CSS, and JavaScript on edge servers closer to users, improving user experience. E-commerce and dynamic content, delivering personalized content and dynamic data, which is essential for fast, seamless online shopping experiences. Software downloads and updates, distributing large files such as game updates, software, and application patches efficiently across the globe. Security and distributed denial of service protection, providing an extra layer of security against cyber threats, including distributed denial of service or DDoS attacks by absorbing malicious traffic. API and application delivery, ensuring fast, reliable performance for APIs and SaaS applications. IoT data distribution, managing and delivering data for Internet of Things or IoT devices. CDNs effectively reduce bandwidth costs and server load while increasing reliability by caching content in multiple locations. The primary mechanism behind a CDN is caching. The origin server is the original main version of the website or application that resides on a central origin server. Points of presence, or POPs, is the CDN provider that maintains numerous data centers, called POPs, in strategic locations around the world, close to major population centers and internet exchange points. The POPs will contain the edge servers that are responsible for storing, caching, and delivering content to the users. Caching. Copies of the website's content, such as static contents like images, video files, and scripts, are stored or cached on the edge servers within these POPs. User requests and redirection. When a user visits the website, their request is automatically routed by the CDN's domain name system, or DNS, to the nearest edge server. Fast delivery. The local edge server delivers the cached content to the user. This significantly reduces the physical distance the data must travel, lowering latency or delay and speeding up load times. Origin fetch if needed. If the requested content is not yet cached at that edge server, the server retrieves it from the origin server, stores a copy for future requests, and then delivers it to the user. The leading providers are Cloudflare, known for its robust global network of data centers, over 300 locations, and comprehensive integrated security features including DDoS protection and a free tier that makes it popular for a vast number of websites. Akamai Technologies, an industry pioneer and generally considered the largest CDN by network size and reach, catering primarily to large enterprises, media companies, and high-traffic websites with demanding performance and security needs. Amazon CloudFront, which is a highly popular and powerful service that is part of the extensive Amazon Web Services, or AWS ecosystem. It is favored by businesses already using other AWS services for seamless integration. Google Cloud CDN. This service leverages Google's massive global network infrastructure, including the same infrastructure used by YouTube, to deliver content with high speed and reliability, making it suitable for data-intensive and streaming platforms. Microsoft Azure CDN. Integrated with the Microsoft Azure Cloud Platform, it is a strong choice for organizations operating within the Microsoft ecosystem, offering scalable and global reach. Fastly emphasizes real-time control, high performance, and edge computing capabilities, making it a preferred choice for companies with dynamic content such as e-commerce platforms and streaming services. Bunny.net, a performance-focused and cost-effective option known for its developer-friendly approach and simple setup, popular among small to mid-sized businesses. Other significant players include CDN Networks, CDN77, and providers like StackPath and Edgio. Many large companies also develop their own in-house CDNs, with Netflix being a prominent example. Question: UDP is best used for what? Answer: streaming media. Question: which of the following technologies is most appropriate for a business that requires high-speed access to frequently used web content such as images and videos? Answer: CDN. Question: which of the following is used to stage copies of the website closer to geographically dispersed users? Answer: CDN. Question: which of the following used to store and deliver content to clients in a geographically distributed manner using edge servers? Answer: CDN. For more information, refer to these sites. In summary, streaming media refers to audio and video content delivered continuously over the internet and played in real time on user's device without requiring the user to download the entire file first. A codec, short for compressor, decompressor, or coder decoder, is a software algorithm or hardware device used to drastically reduce the size of the digital audio and video files for efficient storage and transmission over the internet. A content delivery network, or CDN, is a geographically distributed network of servers that works to accelerate the delivery of web content, including HTML pages, images, and streaming media, to users by bringing the content closer to them. Thank you for watching this video. The next video will be Advanced Networking Concepts, Part 9, VoIP and Wake on LAN. If you like this video, click the like button, and if you have not already, subscribe to the Pat Has Your Back channel. Thank you.